we were discussing oxidation, reduction. We did some questions. We did a lot of questions related to oxidation and reduction. We did some past papers. Okay, we would be doing some more past papers, but before doing oxidizing agent and reducing agent. Okay, oxidizing agent and reducing agent. So, oxidizing agent. Oxidizing agent. Let's suppose oxidizing agent. Oxidizing agent. Oxidizing agent is a substance. Oxidizing agent is a substance which oxidizes other. Which oxidizes other and reduces itself. Which oxidizes other and reduces itself. As this is an agent, what the agent does, just like a traveling agent, he is not going to travel, he is going to make you travel, right? Because you are going to pay money. So basically what the oxidizing agent does, it's not being oxidized, it oxidizes other. As the traveling agent make the others travel, just like that. So oxidizing agent is a substance which oxidizes other, and reduces itself. Let's suppose this is Madarka. Let's suppose I'm just giving you example, okay, bhai, Madarka. So and this is Abdul Wase. Let's suppose, just taking an example, and Madarka is asking money from Abdul Wase. Okay, he's asking 50,000 rupees, 50k rupees. Okay, so basically when Abdul Wase give 50k to Madarka, obviously when Abdul Wase will pay 50k to Madarka, ultimately it's being reduced itself. Reduced means what? The decrease. Okay, so Abdul Wase is oxidizing Madarka and reducing itself. बात समझ आ रही है? उसको तो वो दे रहा है, वहां ज्यादा हो रहा है एंड यहाँ कम हो रहा है. Obviously the money is going to increase and here the money is going to decrease. This is the difference between oxidizing agent and the reduced, like the term. So oxidizing agent oxidizes other but reduces itself. I am repeating, oxidizing agent oxidizes other but reduces itself. Okay, how? In equations, in a reaction, how we can identify whether the substance is oxidizing agent or a reducing agent. Remember, this is very important and very easy. Let me tell you this. But before going into that, I want to tell you the reducing agent as well. So, reducing agent, as you know that reducing agent is a substance which reduces other and oxidizes itself. Let me give you an example. It would make your concept better. Let's suppose I have this equation. I need your concentration. The thing would be easier for you, okay? Let's suppose I have this equation Fe2O3, then I have 3CO, then I have 2Fe, then I have 3CO2. Okay, this is the equation. Examiner would be giving you this equation. Examiner would be giving you this equation. Okay. And then he would be asking, identify oxidizing agent, identify reducing agent, identify oxidizing agent, identify reducing agent. So remember that, let's suppose I am considering this Fe2O3. I need your concentration, okay? Let's suppose I am considering this Fe2O3, okay? Fe2O3 is converted into Fe. Fe2O3 is converted into Fe. It's mean that the loss of oxygen, and you all know that the loss of oxygen is reduction. The loss of oxygen is reduction. Okay, you all people know that the loss of oxygen is reduction. Okay, okay, so I can say that now Fe2O3, I need your concentration. It would be, this topic is tricky, right? But this would be easier for you, so I need your concentration. Let's suppose I can write it down. Fe2O3 is reduced. Fe2O3 is reduced. Okay? Are you all getting my point? Yes or no? Am I right? Yes or no?
Yes, sir.
Good. Fe2O3 is reduced. Why? Abdul Wase, can you tell me why Fe2O3 is reduced? Yes, Abdul Wase? Can you tell me this?
Because the oxygen is lost.
Exactly. So I can say that when something reduces itself, is an oxidizing agent. Okay, Fe2O3 is oxidizing agent. That's it. Simple. So I can tell you that before identifying oxidizing agent and reducing agent, you must know where the oxidation and reduction is taking place. You must know this, otherwise you won't be able to identify which one is oxidizing agent and which one is reducing agent. Remember, okay? And CO is going to convert into the CO2. This is addition of oxygen. This is addition of oxygen, and you know that addition of oxygen is oxidation, है ना? Addition of oxygen is oxidation. So I can say that na कि CO is oxidized. I can say that na कि CO is oxidized. Oh, according to the definition, when something oxidizes, when something oxidizes itself, when something oxidizes itself, when something oxidizes itself is a reducing agent. So CO is a reducing agent. That's so much easy. That's so much easy. So you must know that where the oxidation is taking place and where the reduction is taking place. That's it. Okay, that's it. I'm giving you an example. You are supposed to tell me which one is being oxidized, which one is being reduced, which is oxidizing agent, and which is reducing agent. You have to tell me the four things. You have to tell me the four things. Okay. Okay, now see this. Now see this, MnO4 minus, then I have Fe2 plus, then I have Mn2 plus, then I have Fe3 plus. I'm removing this K, okay? I'm writing down the chart that is minus. Can you tell me, please? I'm giving you only 1 minute. Yes, Amaya, what do you think about that? Anaika, Aryan, Fatima, Hamna, Huria, Mahin, Madarka, Muhaimin. Rennie. What do you think? Umar Khalik. Yes. Ayat Zubair, what do you think, beta? Ayat, बोल भी दो यार, अब जल्दी करो बेटा.
MnO4 is the oxidizing. No, sorry, it's the it's the oxidizing agent, and Fe is the reducing agent.
Okay. Okay, let me explain this. As you know that, as you know that, uh, this is Fe2 plus. As you know that, this is Fe2 plus. It's changing into Fe3 plus. It's changing into Fe3 plus. Okay. So this is increase in charge. This is increase in charge. You know that. Increase in charge is oxidation. Increase in charge is oxidation. You know that I can say Fe2 plus is oxidized. Fe2 plus is oxidized. Something which is oxidized is a reducing agent. Something which is oxidized is a reducing agent. And I can say that FMnO4 minus is changing into Mn2 plus. It's mean that this is a loss of oxygen. When there is a loss of oxygen, according to the definition, this is reduction. This is reduction. I can write it down that MnO4 minus is reduced. It's reduced into Mn2 plus, and this was oxidized into Fe3 plus. I can say that this is an oxidizing agent. This is an oxidizing agent. Okay. Why? Why, if I ask, why this is an oxidizing agent? You are supposed to tell that because it reduces itself. Because it reduces itself. Then I ask how it's going to reduce itself. Then you can tell me that MnO4 minus is changing into Mn2 plus after the loss of oxygen. That's it. That's it. So in this way, you can answer which species is being oxidized, which is reduced, which one is oxidizing agent, which one is reducing agent. That's it. Simple. Okay, today we are going to discuss this. For each reaction in problem 13, identify the oxidizing agent and the reducing agent. We would be doing this, okay? Okay. First of all, you have to decide, then I would be telling you. I'm giving you only 5 minutes. First of all, you are supposed to decide, then I would be telling you which one is oxidizing agent, which one is reducing agent. Okay, start. Just write it down on your notebook so that you can match. Okay. Okay.
First,
Okay. So first, A. A.
Sir, for
Carbon is
option B,
going to okay. Yes. In option B, what
sir, is it HNO3?
is HI? What
HNO3.
HNO3? Yes.
Yes, because nitric acid is losing the hydrogen, like removal of hydrogen.
Okay. Okay. Let me tell you. Wait. So basically, in the first carbon, that is 0. I told you that the oxidation number, the charge of a single element is 0. The charge of a single element is 0. So it's changing from carbon to carbon dioxide. What does it mean? It's mean that this is gain of oxygen. It's mean that this is a gain of oxygen. And you know when there is a gain of oxygen, so ultimately it's what? It's oxidation or reduction. What do you think? When there is a gain of oxygen, it's oxidation or reduction?
Reduction.
It's ox it's It's oxidation. Gain of oxygen is oxidation. Remember, gain of oxygen is oxidation. Okay, gain of oxygen is oxidation. And so I can say that carbon is oxidized. I can say that carbon is oxidized. Okay, I can say that carbon is oxidized. So carbon is a reducing agent. Something which is being oxidized is a reducing agent. Something which is being oxidized is a reducing agent. So this is reducing agent. If you ask, sir, why this is reducing agent? So I would say that because carbon is oxidized itself. How? By the gain of oxygen. So that's why something which oxidizes itself is a reducing agent. Something which oxidizes itself is a reducing agent. What about H2SO4? What about H2SO4? As you know that, sulfuric acid is going to convert into sulfur dioxide. Sulfuric acid is going to convert into the sulfur dioxide. It's mean that this is the loss of hydrogen. No? Should I say that this is the loss of oxygen or loss of hydrogen? What should I say? Can you tell me?
Loss of hydrogen.
Loss of hydrogen. But the thing is that loss of hydrogen is also oxidation. Loss of hydrogen is also oxidation because water is also formed. Water is also formed, remember. So in water, there is hydrogen involved. So you are not supposed to consider hydrogen. You are not supposed to consider hydrogen. You are supposed to consider oxygen. When there is a confusion, remember, let me tell you one thing. In a redox reaction, this is mandatory that the first species is oxidized and the other species is reduced. Like I mean to say that if the single species is oxidizing agent, ultimately the other species would be the reducing agent. Remember, so it's mandatory. So I have decided, as you have decided, that the carbon is a reducing agent. It's mean that it shows that the other species would be the oxidizing agent 110%. Okay, so let me explain this how we are going to consider the sulfuric acid. So sulfuric acid means it's changing from H2SO4 to sulfur dioxide. As you can see that these are the 4 oxygen atoms and these are the 2 oxygen atoms. So I can say that this is the loss of oxygen, and you all know that according to the definition, loss of oxygen is reduction. Loss of oxygen is reduction. So I can say that the sulfuric acid is reduced. The sulfuric acid is reduced. And I told you that something which reduces itself is an oxidizing agent.
Sir.
Oxidizing agent. Yes.
Sir, what about the loss of electron? That's not related to here.
Loss of electron.
Hmm.
Like you're supposed to consider the charge. If you are going to consider the charge, so you can also consider this by, because after considering this, you can also tell what the process is going to take place. Let's suppose you must know what is the charge of sulfur in H2SO4. You must know what is the charge of sulfur in H2SO4. Okay, let me calculate the charge of sulfur in H2SO4. I'm going to calculate over here. As you all know that, the charge on hydrogen is +1, and in H2SO4 you have 2 hydrogen atoms. This is the sulfur, and you have 4 oxygens. Each oxygen is -2. Each oxygen is -2 is equal to 0. Each oxygen is -2 is equal to 0. So that would be 2 into 1 is 2, then sulfur, then plus in minus minus. 4 into 2 is 8 is equal to 0. Then 2 minus 8 is -6. Sulfur is equal to 0, and sulfur is equal to +6. So I can say that the charge of sulfur in H2SO4 is +6. The charge of sulfur in H2SO4 is +6. And also, if you are going to consider the charge of this SO2, like you can say that what is the charge of sulfur in SO2? So I can say that this is the sulfur. You have two oxygens. Each oxygen is -2 is equal to 0. That would be -4 is equal to 0. And that would be equal to +4. I can say that the charge is going to decrease. I can say that the charge is going to decrease. +6 to +4. +6 to +4. And you know that the decrease in charge is reduction. You know that the decrease in charge is the reduction. And something which reduces itself is an oxidizing agent. Finally, we have decided that carbon is a reducing agent and sulfuric acid is oxidizing agent. Are you all getting my point? Yes?
Yes.
Okay. So you have multiple ways to think. You have multiple ways to think what's the happening. You have multiple ways to think whether you are going to consider the loss of or gain of hydrogen, whether you are going to consider the loss or gain of oxygen, whether you are going to consider the loss or gain of electron. Okay, you have multiple ways. So you if you are thinking that it might be difficult for you, so you can opt another method, but your answer should be correct. Like, let's suppose any person, let's suppose using different methods, so they must have the same answer. They must have the same answer, because examiner would be asking identify which one is oxidizing and which one is reducing agent. So just you have to identify, that's it. What the method you are going to opt, it's up to you. Yes, now I'm going to the second equation. Second equation, HNO3 plus HI. Okay, IHI. This is I2. This is the loss of hydrogen. This is what? The loss of hydrogen. So the loss of hydrogen is what? The loss of hydrogen is what? Sorry?
Oxidation.
The loss of hydrogen is oxidation. Exactly. The loss of hydrogen is oxidation. So I can say that HI is oxidized. HI is oxidized into I2. So HI is reducing agent. So HI is reducing agent. Okay. And if we talk about HNO3, so HNO3 is going into NO. HNO3 is going into NO. Okay. So means that this is the loss of oxygen. This is the loss of oxygen. Exactly. So HNO3 is reduced. HNO3 is reduced into NO by the loss of oxygen. Hence HNO3 is oxidizing agent. It's very simple. Enjoy the party. It's very simple, okay? Yes. Now consider the third equation.